Linear inequalities are very similar to linear equations, the only difference being that linear equations have equal signs, and linear inequalities have greater than or less than signs. The method for solving linear inequalities is the same for solving for lines. The difference being that for lines, I'm solving for a particular number, and I will get a line as a result. For inequalities, I'm not looking for a number equal to something. I'm looking for a series of numbers that are greater than 6 in this example, where here I'm only looking for the numbers that are equal to 6. Here, any number greater than 6 that 2x plus y equals is part of the solution of the linear inequality. So to go about graphing a linear inequality, I graph it like a regular linear equation. For the moment, I ignore the sign. I graph it like a line. However, in inequalities, I can have less than, greater than, less than or equal to, greater than or equal to. If it's not or equal to, then the line itself is not included, and I draw it as a dashed line. If the line is included, greater than or equal to, so if there's a bar under here, if y was greater than or equal to minus 2x plus 6, then the points on the actual line would be included. The numbers that actually equaled 6 would be included, but in this example they are not. So when I draw the line, I do not include the points on the line, and I draw it as a dashed line. Now, the final step to a linear inequality. Here I've already solved it and drawn them out in order to save time. But ordinarily, I would not, sometimes, well, right now I would be able to look and tell, but sometimes I'll get an equation where it's not readily apparent which part I should shade. And I have to shade things above or below because it includes all points that are greater than or equal to. For 2x plus y, I could say x is equal to 1,000,000 and y is equal to 3. I could say x is equal to 1,000,000 and y is equal to 4. X is equal to 1,000,000, y is equal to 5. Or I could say x is equal to 2, y is equal to 1,000,000. And all of those values would be greater than 6. So if it is not readily apparent, what I can do is test points. Let us say that I do not know already which part of the graph to shade. What I would do is I would pick a point either above or below the line and test. And if I get a true statement, then I shade that part of the graph. If I get a false statement, then I shade the other part of the graph. Let me pick, usually the best point to pick is 0, 0. Unless the line travels through the graph, 0, 0 will always be available for me to choose. If I have this equation and I put in 0, 0, I'm going to get 2 times 0 plus 0 is greater than 6. 0 is greater than 6, which is a false statement. Actually, it wouldn't really be an equals, just false. So I would shade the other part of the graph. And in fact, I've already drawn this. 2x plus y is greater than 6. I have drawn that. If it was 2x plus y is greater than or equal to 6, then this line would be shaded. In this example, I did not shade in the line because the values that equal 6 are not included. It's greater than 6. Not including 6. If it was 2x plus y is less than or equal to 6, then I would shade below. And that's all there is to inequalities, linear inequalities anyways. They're very simple. It's just like graphing a regular line and then testing a point either above or below if it is not readily apparent which part to shade. Test a point. If that point is true, that half that the graph is on is shaded. If the point is false, then the other half is shaded.